Hey guys, my name is Reno, and today I'm going to be teaching you about equations of parallel and perpendicular lines. Alright, so first off, the slopes of parallel and perpendicular lines. So the slope of parallel lines. In a coordinate plane, any two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel because they're straight. So here we have a diagram. So M represents a slope. So as you can see here, these two are only parallel or only equivalent only if their slopes are equivalent. Next, the slope of perpendicular lines. In the coordinate plane, any two non-vertical lines are perpendicular if and only if their product of their slopes are -1. Horizontal lines are perpendicular to vertical lines because that's pretty obvious, they create a 90-degree angle. Alright, so as you can see here, the product of the blue line, the slope of the blue line, and the product of the slope of the red line are equal to -1, which tells us that these two lines are perpendicular. Alright, so identifying parallel and perpendicular lines. Determine which of the lines are parallel and which of them are perpendicular. Pause the video, give this a shot, and come back for the right answer. Alright, so now that you're back, so the answer. Slope of line A. So, as you know, the formula for slope is y2 minus y1, 3 minus 2, and y2 minus x2 minus x1, 0 minus -3. And then you do that, we get a final value of 1 over 3, as because 3 minus 2 is 1, and 0 plus 3 is 3, because the negatives cancel out and become a positive, or a plus. Next, the slope of line B, same formula, 0 minus -1, and 2 minus 0, which gives us an m value of 1/2. Slope of line C, m is equal to -4 minus -5, and 1 minus -1, which gives us a final value of 1/2 as well. And slope of line D, m is equal to 2 minus 0, right here, and then -3 minus -2. This uses this point for the purple line as well, and this point. When we do that, we get a slope value of -2. Alright, so now for identifying which of these lines are parallel and which of them are perpendicular. So, as we learned, if two lines are parallel, then their slopes are equivalent. So as we can see, line B and line C are going to be parallel. And then lines D and B and B and lines D and C are perpendicular because when you multiply -2 and 1/2, you get -1. Which is the requirement of the slopes for two lines to be perpendicular. Alright, so writing an equation of a parallel line. Write an equation of the line passing through point -1, 1 that is parallel to the line y is equal to 2x minus 3. Use the slope of the parallel lines theorem that we learned about. Pause the video, try this out, and then come back for the right answer. Okay, so now that you're back, so the answer. Find the slope of the line given to you. So that's the equation of the line. So slope of line y is equal to 2x minus 3. And the slope of the line is 2 because the m value in the equation is 2. So the new line also has a slope of 2 because we're trying to find a line that is parallel to this line. So as we learned, the slopes of parallel lines are equivalent. So that's also the new line is also going to have a slope of 2. Next, finding the y-intercept using the slope and the given point. We can use y is equal to mx plus b because we have our x and y coordinates and our slope. So when we plug in our values, we get 1 is equal to 2 times -1 plus b, and then we get 1 is equal to -2 plus b, and we add 1 and -2, we get b is equal to 3. And then the equation of our new line is going to be y is equal to 2x plus 3. That's going to be our final answer. Alright, writing an equation of a perpendicular line. Write an equation of a line passing through point 2, 3 that is perpendicular to line 2x plus y is equal to 2. Pause the video, give it a shot, and come back for the right answer. Okay, so now that you're back, first off, find the slope of the given line. So 2x plus y is equal to 2, or y is equal to -2x plus 2. It's the same thing, we just moved the x variable to the other side. We got y all by itself. Alright, so finding the slope. So the slope of the line is -2, as you can see here. The m value here is -2. but we need to use the slope of perpendicular lines theorem to find the slope of the new line. We know that perpendicular lines, their slopes have a value or a product of -1, so we need to find what number multiplied by -2 gives us a value of -1, and that's going to be 1/2. So that's going to be the slope of our new line. Now this is just the same as last time. We're going to plug in our values, the x and y coordinates of the point that was given to us, and then the new slope into the y equals mx plus b formula. Then we're going to find our b value or our y-intercept. So y is equal to mx plus b. So the y value is 3 is equal to m 1/2 times 2 plus b. 3 is equal to 1 plus b. Then we're just going to subtract 1 from both sides, which gives us a b value of 2. So the answer, or the new equation of the line, is going to be y is equal to 1/2 x plus 2. 1/2 being our slope and 2 being our intercept. Alright, find the distance from point 1, 0 to the line y is equal to -x plus 3. You're now asked to write a formula or equation here, finding the distance. Pause the video, give it a shot, and then come back for the right answer. Okay, so now that you're back, we're gonna take a look at what we learned last lesson. So we learned that a distance from a point to a line is a perpendicular segment, the length of the perpendicular segment. So we know that this is going to be a perpendicular line to this given line here. So first, find the slope of the given line. The slope of the given line is going to be -1 because there's just a -1 there, even though it's not visible. We know that if there's a negative in front of a variable directly, then there's going to be a 1 there. So -1. Now we need to find the slope of a perpendicular line. -1 times m is equal to -1. What gives us that value of -1, or the product of -1? That's going to be the 1. The slope of the new line is going to be 1. Alright, so now we're going to do the same thing that we've been doing earlier. Plug in our x and y coordinates and our new slope to find the y-intercept of the new equation. Y equals mx plus b. 0 equals 1 times 1 plus b. That's just going to give us b is equal to -1. So the equation of our new line is going to be y is equal to x minus 1. Now we're going to do 2 equations. I hope that you've learned how to solve this. If not, I'll still go through it. So y is equal to x plus 1 and y is equal to -x plus 3. You should have learned how to do this in Algebra 1. If not, here goes. So we're going to plug in. There's multiple ways of doing this. You could eliminate x by multiplying the top equation by -1. You could do that, or you could simply just substitute the y in the second equation with the x in the first equation. So that's going to give us x minus 1 is equal to -x. So our 2 equations are y is equal to x minus 1 and y is equal to -x plus 3. And we're just going to plug in our values. And then now we're going to bring the x value here and the constants to the other side. So that's going to give us, that'll give us 2x is equal to 4 because x plus x equals 2x, and 3 plus 1 is equal to 4. So when we divide 2 from both sides, that gives us the x value of 2. And then next, we're just going to plug in into our first equation, our x coordinate, or our x value, y is equal to 2 minus 1, which gives us a y value of our second coordinate point of y is equal to 1. So now we have our 2 points, 2, 1 and 1, 0. Now to find the distance between them. And by the way, this is the point where the second line intersects with the first line, just for you guys to know. And then now we're going to do our distance formula, x2 minus x1 squared plus y2 minus y1 squared. Let's plug in our x and y values, 1 minus 2 squared plus 0 minus 1 squared, and then -1 squared plus -1 squared, which gives us the square root of 2, which approximately equals 1.4. So the distance from a point 1, 0 to the line y is equal to -x plus 3 is approximately 1.4 units. If you guys found this video educational, leave a like, subscribe, and come back for more educational videos like this.